If you see our linear regression problem, you will observe that there are some data points which are real observations, and our goal was to draw a best fitting line. Even though this line here is the best fitting line, still there is error, and that error is the difference between the actual data points, which is like this, and the predicted value. So this point here on my line is the prediction for this point here is a prediction for this observation, and this is the prediction for this, and so on, right? So if you see the difference between the actual value and predicted value, this is actual value, okay, so let me say actual, and this is predicted. Okay, the difference between actual and predicted value is error. So let me denote the error for this observation number 1 as E1, observation number 2 as E2, for 3 E3, and so on. This continues till En for observation number n. So if you sum up all these errors, you will get some measurement regarding the error we have in our modeling. So what we do, we will sum all these errors, E1 plus E2 plus E3, and so on till E9, correct? Now say one thing here, this point and this point, the difference between this point, the actual value, and predicted value here is positive, because this line is this point is above the prediction, but the difference here, okay, between the actual value and the predicted one would be negative, since this actual value is below the prediction. So in this way, what happens, if we try to sum up, we will not get the magnitude of error. Instead, there is some positive value and negative value, both would cancel each other, right? So rather than just summing the errors, we can take either absolute value of it, okay, absolute value of it, okay, and that is called absolute mean error. So the formula for absolute mean error is like this. Let me write it. The absolute mean error is equal to let's say y is our actual value and y hat is our predicted value, right? And for observations I equal to 1 till n are there, so for ith observation I have yi and y hat I. So this is my error, this is my E of I here, right? If we sum all of these, we can write it like this summation, and I equal to 1 till n, and then we take absolute value of the error, y of I and y hat of I, correct? Now we wanted to take mean of it, so we will divide the whole thing by n, and that's the formula for absolute mean error. Okay, now there is one more thing, one more trick in order to get the positive value of this error. Rather than taking the absolute value, okay, absolute value, we can take a square, okay, we can square it, right? So for example, let's say I have error as -5. If I will square it, what will happen? It will be -5 into -5, and that would be equal to 25. So I am getting a positive number. So the second kind of measurement is a square mean error, okay, and the name itself is explanatory. Everything remains same in this as well. Instead of absolute value, let me just clear the screen, we have a square mean error. So a square mean error is equal to summation from 1 to n, okay, and this time rather than taking the absolute value, what I am doing, y I minus y hat I, and taking a square of it, so that this difference would be positive, and in order to take the mean I'll just divide it by n. Okay, and there is third kind of measurement, which is root mean of, okay, a squared mean error. Okay, and this is eventually the same thing, but just the root mean of this squared mean error. Okay, so let me just write the formula. This is equal to root mean of a squared mean error is equal to 1 by n from I equal to 1 till n, and then yi minus y hat I n square. Okay, now root mean squared error is most popular measure for this evaluating the performance of our model, since if you see if you are getting a squared mean error, you will be getting a very large number because you have squared it. Okay, and that would be a bit difficult to interpret, right? So rather than taking this measure, we generally take root mean squared error. Okay, but you can use any one of these measure just to evaluate your performance. So this is about measuring the performance of your model. I'll see you in next video.